Alright, hey everyone, I'm Mr. Pritchard. I am here today to teach you about one of the most important things in science, and that's energy. Okay? And there's a lot of misconceptions about energy that I hope I can help you with or clear up some of those misconceptions. Okay, one of the major things you need to know about energy is it is not created, nor is it destroyed. Okay? It just transfers from one place or one storage to the next. Okay, you don't use it up. It doesn't disappear, okay? It just transfers from one place to the next. All right, so I also have up here 8 energy stores. So these are the 8 places that energy is going to be stored and where it's going to transfer to. So it could go from chemical to thermal, gravity to kinetic, okay? So that's just how it works. So an example, I have this candle, okay? And it goes from chemical energy, which is stored in the wax, okay, in the wick, and it then transfers to thermal. Okay, so you get a flame, and the energy is transferring in as this flame. You get your thermal energy storage. Okay, so in that case, it goes from chemical to thermal. Another example, which I'm going to show you so you can visually see if somehow I can show you how to visually imagine energy transferring from one place to the next. I have this desk fan here. Now, when I turn it on, what we're going to get is an electric energy store is going to transfer to the fan. The fan is going to spin, so we get a kinetics energy store then. So it's going to go from electric to kinetic. And how I'm going to get you to visualize this is I have some water. Okay, and I use some green food coloring, okay, in honor of St. Patrick's Day. All right, or as you say it here, St. Patrick's Day, right? Yeah. Oh, sorry, it's water, or water, not water. Anyways. So on this one you see electric, this is where the energy is stored. And when I turn the fan on, okay, this energy is going to transfer into kinetic, and that's the fan blades turning, alright? So watch what happens. I'll turn the fan on, and it's spinning. So what we're actually seeing is the electric energy transferring into kinetic. And that's how you can visualize energy transferring from one storage to the next. Now obviously this is a continuous electric supply right now that's going to keep transferring in the kinetic. Now another thing that you might want to know is that this fan is actually vibrating, making noise, and the motor is giving off heat. So while this energy is transferring in as kinetic into the fan blades, it's not all transferring to the fan blades. Some is going to dissipate into the atmosphere as heat, some is being lost through vibration, okay, or transferring into vibration. So this is what's really probably happening, okay? So electric, kinetic, and all that's laying lost at the side is probably the energy that's dissipating into the atmosphere as heat. But most is going to kinetic. Alright? And that's how it would work. So that's where energy would dissipate into the atmosphere. All kinds of appliances, the quieter the appliance, the more energy efficient it is. It's the less energy you're losing to vibration and heat and sound. So the quieter running appliances, more efficient. How can we use this energy, how can we use this? Well, this will help you understand other topics as you go throughout science. Physics, chemistry, and biology, you need to know that energy transfers. For example, one big topic you're going to do, just so you can use this, is specific heat capacity. And the way you can understand this is an object's capacity to store energy. So how much energy you can store in this object as heat is a specific heat capacity. So think about the beach in the summer. The sand can generally get quite hot, but yet the water stays cool. Now, why is that? Now see if I can visually get you to see this. Here's water, here's the sand. You can see it marked. Now, I'm going to lay these here so you can see them. Going to get messy. I don't care now. I'm moving this tub. And I'm going to consider these two here generic. This is sun. This is energy from the sun beaming down on both. Alright? So, both at the same time, you're going to see why the sand feels hot and the water feels cold. Now, if you look what happened, the water its ability to hold more energy means it's going to stay quite cool for much longer than the sand gets quite hot right away. Okay? It has less of an ability to hold or have capacity for energy storage than water. Therefore, it's going to feel much more hotter. Its specific heat capacity is less than water. That's just one way you can use knowledge of energy stores, how it's transferred, to help you understand some of the other topics you're going to be learning or hopefully revising now in science. Thank you very much.